Welcome to Electronics for Fun, Topic 3, Resistors. This part here is Ohm's Law. Ohm's Law is a law that tells you if you have two known values such as voltage or amps, or voltage or current, or even voltage with resistance, when you need a kind of pair like that, you can solve for the third one. You can look at the triangle to help you memorize it. On my site, it has a pie chart which has all 12 formulas. For the power one, it can be easy. You just remember one power one, you can figure out for all of them. But it'll be a lot less work if you did one for the certain combination. Anyway, let's get going. First, we have a 5 ohm voltage source going to a resistor on this one, which is 50 ohms. To figure out what we need to do what its resistance is, we must take for 50 ohms in R and 5 volts in the V, and that makes it V over R, or voltage divided by resistance. So what we'll do is we'll take 5 it'll zoom in good. Here we go. 5 divided by 50 equals 0.1 or 100 milliamps. Now we have this trickier one, but it's not that very tricky. If you know the rules of series and parallel resistances, these two are in parallel. This is in series with that one there, so it can be simplified to one resistor. Such as this one can be simplified to one resistor. And the whole thing can be simplified as one resistor as well. We're gonna have, then for the voltage, we're gonna have 5 volts across it. And right here we have 1 ohms there. First, it's in the 5. We'll put the 5 in. We'll put the 1 in first to solve for it. 1 plus. And since these are the same value resistors, 2/8 of them, each one is 8 ohms resistors. We put in parentheses 8 divided by 2. There's 4, and add it together equals 5. Now, in the last two we have, there's 2.5 ohms for each of these two resistors, and they're put in series, so they add up. So then if you add 2.5 together, times you can take 2.5 times 2. Gives us 10. The total resistance of this whole thing is 10 ohms. I haven't showed that in the series of resistance one. I should have did this earlier, but I didn't, and I should have tried the example with more than 1. Now let's go back to our original equation. Original answer question. What is 5 ohms, 5 volts at 10 ohms? What is this current? So we must solve for current. We know that it's 10 ohms for the whole west of the circuit here. The whole circuit here west of it can be supplied to one 10 ohm resistor instead of having all these whole bunch on it. It can be simplified because that's basically what it is. Now, sometimes you might want to do parallel and series combinations to help with the wattage. Wattage is important. That's why I put this formula here: P equals V times I. We'll go over each one of these, the wattage for each one of the problems we just did in a few minutes after I show you how to finish this last one. We're going to take 5 volts, so 5, that's 8, 5. And we'll divide it by 10. Which is a half amp. Now, let's say we want to figure out what wattage the resistors have to be. Now, not all of these resistors have to be that. Well, probably they do, because they probably will have, if one of these resistors, if the resistors in parallel are bigger resistors where the resistance is okay with the wattage at that certain resistance, then it's okay. But since these are 8 ohms, they will need to have the exact wattage since they're not higher than that, where 5 volts would go higher than it. You could probably go with lower wattage, but not that low as you would expect to go. Anyway, let's put in a V is 5. We're going to times it by 0.5. Gives us 2.5 watts. So this resistor here is 2.5 watts. Now what about this one? We say, what did we say it was? I think we said it was 100 milliamps, so it would take 5 times 100 milliamps. It gives us half a watt, 0.5 watts. And there you go. You can do this in real life. You can try out an experiment with the kit you got by using the resistors in it and measure it and see if they actually go with the calculations. They should. These resistors have tolerance, so we'll talk about tolerance later on. We'll talk about tolerance and go over that. Anyway, let's end this video with that. So I hope you enjoyed this video. Thanks for watching. Hope you like it. And please join my online course if you haven't joined yet, okay? Hope to see you there.